Good day, good day. Just a reminder, your test is a week from today. I will be in my room during flex blocks this week, except Wednesday is my flex prep block H, so if it's okay with you, I'll shut down on Wednesday. Friday, I will try and keep just for my grade 12s. I'll let my grade 11s know to go elsewhere on the Friday. Okay? A car is moving east. You know what? I've been humbled. I shall put that there. It collides with a truck. Okay, Robbie, there is a collision. And I see angles, which means I'm going to be doing some trig. Find their velocity, magnitude, and direction after the collision. So I'm going to start out by saying the sum of all the momentum before equals the sum of all the momentum after. Of course, you're not just foolishly copying this out, Mr. Robbie. You're instead going to try this quiz on your own and then mark it yourself, because that would be good learning, right? Right. So I know this is a conservation of momentum question, not an impulse or a force question. By the way, the other guideline for that is typically if it's an impulse or a force question. Did I hear your phone go off? I thought I... Did I? No? Okay. It'll be one object. It might be one object hitting a wall or something like that, but primarily it's going to be one object moving. Not always, but usually. Before the collision, I'm going to call this, how about C for car and T for truck? So before the collision, what's moving? Both separate. So I'm going to have momentum of car initial plus momentum of truck initial. Robbie, what does the equal sign stand for? And they do. This time it looks like they stick together. I'll have to make sure I remember that when I divide by masses. I'll be dividing by the mass of both later on to get the V by itself. I'm going to draw a little picture here. Car is going due east, so the car is going to go that way. Its momentum is going to be 39,000. I can do that in my head. 13 times 3. Add some zeros. Plus, the truck is 60 degrees north of east. North of what? North of east. North of what? North of east. Start out going east. I'm going to go north of east, back to where I started from. 60 degrees is pretty steep, about like that. Maybe not quite that steep, but close. And this one is going to be 3,200 times 20, which I think is going to be 64,000 if I do the math in my head correctly. And that equals, I don't know, but that's okay. I have two vectors on the same side of my equation. I can add these together tip to tail. As a vector triangle, it's going to look like this. 39,000. And the 64,000 should be almost twice as long as the 39,000. Should certainly be longer. It looks like what I'm looking for as a vector triangle, that's the momentum of both after the collision. Also, it looks like this angle right here is 60 degrees. No, that's not right, Mr. Dewick. That's totally wrong, Mr. Dewick. Good gosh. It looks like this angle right here is 60 degrees, which isn't in my triangle. Or is it? This is not a zangle. A Z doesn't work when it's all yucky slanty, so this is not a Z. The Z trick only works when the top and bottom are parallel. How can I get an angle in my triangle? Okay, the straight line forms 180 degrees, so this angle here must be 120 degrees. Good stuff. Now I can start to do my cosine law. It's going to be the momentum of both squared is going to be 39,000 squared plus 64,000 squared minus 2, 39,000, 64,000, cos 120. I'm going to get 39,000 squared plus 64,000 squared minus 2 times 39,000 times 64,000. Cos of 120. Square root, Mr. Duick. Sheesh. I get 90,072.2. I get momentum both equals 90,072.2. So the velocity of both is going to be this number. I did one too many zeros there, didn't I? 72.2 divided by the mass of both, which is 1,300 plus 32, 1,300 plus 3,200. So to my calculator, I'm going to divide by 1,300 plus 3,200. Did you get a speed of 20.0? Now I need a direction at. Oh, this direction isn't too bad. It's always where the vector starts from. I think this is what I'm going to want as my theta. I think I can find that using the sine law. I think I can go the sine of theta over what's across from it equals the sine of 120 over what's across from it. 64,000 times the sine of 120 divided by 90,072.2. You could also have reversed engineered this and gone with your answer button, but since that's a 0.19, the 0.2 is a nice rounding off point anyways. It shouldn't make a big difference. Inverse sine of that, do you get an angle of 38 degrees? And that'll be north of east. Of course, I would also accept an east of north angle, and that east of north angle would be 90 minus 38, which is 52 degrees. Now, if you got this, you get 7 out of 7. Otherwise, how would I give out part marks? 1 mark for the magnitude, 1 mark for the direction. I would give you 1 mark. You know what, Mr. Duick? Don't use black. Use blue because you drew the diagram in black. Let's try that again. I would give you 1 mark if I saw that, just for knowing that it was momentum. That's 1. I would probably give you 1 mark for this. No, I'll take that back. I would probably give you 1 mark for the 39,000, 1 mark for the 64,000. I would give you 1 mark for the cosine law. That's 4 marks. I would give you 1 mark for the sine law. That's 5 marks. 1 mark for that, and 1 mark for that. Something like that I think I would do. You know what? I'll even take back, rather than giving you the mark for the sine law, I would absolutely give you a mark if I saw that 90,072.2, because a common mistake, kids forget to divide by the mass, or they forget to square root or something like that. Is that okay? Let's try another one. Pendulum is hanging from a frictionless, massless string that is 4 meters long. I think this is what we're talking about here in my rough sketch. A bullet is traveling at 380 meters per second. It hits the pendulum and sticks inside. What height will they combined masses reach as they swing up after the collision? That's a good question. So I'm going to divide this into 2 sections, I think. I'm going to have the collision section and the swing section. I think the collision, this is a job for conservation of momentum. Before the collision, what's moving? I have momentum of the bullet. Wham, they collide, and I have momentum of both afterwards. And I can make this initial and this final. Thankfully, this collision is in a nice straight line. Woohoo! So I can say mass bullet v bullet equals mass bullet plus mass pendulum v final. I can say v final is going to be the mass of the bullet, velocity of the bullet, divided by mass of the bullet plus mass of the pendulum. What was the mass of the bullet? 0.015. Velocity of the bullet was 380 divided by 0.015 plus, I think it was 2.4, is that right? Cool. I get the final velocity or speed of the bullet is going to be, technically I'm getting a speed because I haven't included a direction, but we can treat it like a velocity. 0.015 times 380 divided by 0.015 plus 2.4, and I get 2.36 meters per second. Now I'm going to take that, and I'm going to move it over to the swing. The swing has a change in height, change in speed, curvy path. That's a job for conservation of energy, not conservation of momentum. Are any of these zero? I think Prince Edward Island, which we all know, and I think kinetic energy final. At the top for a split second it's come to a stop. So I'm going to get a half m v initial squared equals m g h final. Now this mass is the mass of both. I would normally say be really careful, but conveniently the masses cancel. In fact, I think I'm going to get the final height is going to be v initial squared divided by 2g. It's going to be 2.36, I think it was, squared divided by 2 times 9.8. It's going to be this number squared divided by 2 times 9.8. Do you get 0.284? If you got that on this question, you get 7 out of 7. Otherwise, I would probably do something like this. I would give you 1 mark if I saw that. I would give you 1 mark if I saw that. I would give you 1 mark for getting V final. I would give you 1 mark if I saw that you had used conservation of energy. I would give you 1 mark if I saw this equation. That 1 mark for the answer. That's 6, Mr. Dewick. Where are you going to give him 7 marks, Mr. Dewick? That's a great question. I need to throw 1 more mark out there. You know what? I'd probably give you 1 mark if I saw that. I don't know, something like that. Bonus. Suppose the pendulum only reaches a height. Okay. Find heat. I'm still going to start out with conservation of energy. But this time, I'll add heat. Now, it's important for me to think about where is the beginning. I think the beginning is before the collision. And the final is at the top of the swing. Before the collision, I think all I have is a half mass of the bullet, V of the bullet squared. No potential energy, we're putting ground level there. Afterwards, I have, at the very, very, very top for a split second, I'm going to have mgh final, but this mass is going to be the mass of both of them stuck together, plus heat. So I think if I want to get the heat by itself, the heat is going to equal a half m bullet v bullet squared minus m both gh final. It's going to be 0.5. Mass of the bullet is 0.015. Its initial velocity squared, that's how much energy we poured into the system, all the kinetic energy. At the very end, we had 2.415, I can add that in my head, I think, times 9.8 times 0.15. How many joules of heat do you get? 0.5 times 0.015 times 380 squared minus 2.415 times 9.8 times 0.1515, Mr. Dewick. Double check my typing. Looks good. 1,080? Joules of heat. Okay. And then we can turn the page. On your test, there's going to be an explosion question. It's not going to be quite this tough. This question was tougher because I made the explosion go off at yucky angles. On your test, the explosion that I give you will be a lovely right angle. So, a 100 kilogram shell explodes, boom, into 3 fragments. Fragment A is 40 kilograms, sorry Robbie, but it had to be done, and flies off 32 meters. Okay, I've turned the page. I'm going to put a compass rose here. This is an explosion. This is a job for conservation of momentum. Before the explosion, what was moving? Nothing. So I guess after, I'm going to have momentum of piece A, momentum of piece B, momentum of piece C. And if I draw these as a picture, piece A, 30 degrees north of east. North of what? North of east. North of what? North of east. 30 degrees. And that's going to be 40 times 32. Well, 20 times 32 would be 640. 1,280? 1,280, I think, yeah? No? Yeah? It's my 2 times table. I should be able to do that. Fragment B flies off due north. 25 times 48. 1,600? No, that's wrong. 800. 1,200. 1,200. Plus mystery, don't know piece C. Well, I got 2 vectors. I want to add them together. James, how should I draw them if I want to add them together? How would I draw them if I want to add them together? Thank you. I was asking you a question there. You're back now? Because you were elsewhere for a little bit there. So, James, my friend, it's going to look like this. 1,280. And I'll draw these roughly the same length because 1,280 and 1,200 are pretty close to the same length. Now, if I was just adding these tip to tail and wanted the resultant, I would draw it that way. That's not what I want to do here. I want to add on a 3rd vector. But even though I don't know what it looks like, I know what the answer is supposed to be. What are they supposed to add to? 0, which means this vector is going to be a vector that comes back where it starts from. I'm going to point this vector back to where it comes from. This is the momentum of piece C. Now I need to get an angle. This is really the tricky part, I think, in this question. Well, I know this angle is 30 degrees. Let's zoom in. Here's what I said. If I put in a Z in my head, how big is this angle right here? 30. How big is this angle right here? So how big is this whole angle? 120. There may have been other ways to get an angle, but for me, I said, hey, that's 120 degrees. That works for me. And now I can bring in my old friend, the cosine law. The momentum of piece C squared is going to be 1,280 squared plus 1,200 squared minus 2. 1,280, 1,200 cosine of 120 degrees. 1280 squared plus 1200 squared minus 2 times 1280 times 1200 cos of 120 degrees. Square root, Mr. Duick. Do you get 2148? Momentum of piece C is 2148.1. So the velocity of piece C is going to be 2148.1 divided by the mass of piece C. They didn't tell me the mass. Or did they? How? Oh, they told me the total mass, so I can go 100 minus 40 minus 25. 35. Cool. Oh, that was dumb. I wanted to keep that on my calculator. 2148.1154553 divided by 35. I'll do it the long way. Do you get 61.4? Is that right? Mm-hmm. Yep. 61.4 meters per second. That's the speed. Now, how else could I tweak this question? Instead of saying find the final velocity of mass C, I could have said how much kinetic energy does it have? You could stop here, and now you could go a half mv squared. You wouldn't need to find the theta. You just go straight to a half mv squared. That'll work. I guess I could say what was the total kinetic energy of the bomb? You'd go a half mv squared of each piece and add them up. I'm trying to think of ways I can mix and match this tie, but those are some, and bring in some work energy, to, because that's also conserved. For now, though, I just asked for the velocity, so at, and I think our theta we want is always where the vector comes from. That theta works because it is next to a vertical line. This is going to be west of south. Start out going south and go west of south. So it's going to be west of south, and it's going to be the sine law. The sine of my mystery angle divided by what's across from it, which is 1280, equals the sine of the angle that I know divided by what's across from it, which is 2148.1. Which is that number there. 1280 sine 120 divided by, I'll use my answer button since I now have that stored. Shift sine of that. Do you get 31.1 degrees? Really 31 degrees? West of south? Or 90 minus 31, 59 degrees south of west. You'd probably get that angle if you'd drawn the 1200 first and then drawn the 1280 next. And your triangle will look slightly different, but our cosine laws and sine laws will have the same numbers in them, I think. Just for consistency, let's make that in red. Part marks, if you got that right, 2 out of 2. Otherwise, I would probably go 1 mark for that, 1 mark for that, 1 mark for that. That's 3. 1 mark if I saw that, that's 4. 1 mark for the speed, that's 5. 1 mark for the direction, that's 6. And I would give you 1 mark if I saw that you'd used the sine law somewhere along the way and done it correctly. But if you got the right answer, 2 out of 2. Is that all right? Last one! I think this one actually ended up being a bit easier. I thought I'd made up a tougher question, but because I gave you both angles, it ended up being a little cleaner. Once again, compass rose. Curling rock is traveling due east. It strikes a stationary rock after the... Okay, there's a collision. The sum of all the momentum before the collision equals the sum of all the momentum after the collision. I'm going to call this rock 1. I'll call this rock 2. curling rock before the collision, I think all we have is rock 1 moving before the collision. I think. It strikes, wham! They collide, a stationary 4.1 kilogram rock. After the collision, the first rock is moving at 8 okay. The first rock is moving 38 degrees north of east. North of what? North of east. North of what? Go east. 38 degrees north of east. And, oh, hang on. Why am I drawing that already, Mr. Dewick? I still got to do this algebraically. Momentum of rock 1 final, they don't stick together. Sorry, there's my momentum equation. Now I dulp. This works better because now I have this coming in, which is that's the mystery momentum. I know what it looks like. I just don't know how big it is. They didn't give me the velocity. Now I can go 38 degrees north of east, and this momentum is going to be 3.2 times 8.2, 26.24? Is that right? I typed that in wrong. No? 26.24? I think I did it wrong last year somehow. 26.24. I think I made a typo last year in my answer key. That's a mistake. The second rock moves 48 degrees south of east. South of what? South of east. South of what? So I'm going to go east. I'm going to go south of east 48 degrees. And it's going to have a momentum of 4.1 times 5.4. 22.14? Oh, I can add those two together, tip to tail. That'll work. So if I do that, I'll get 26.24, 22.14. I guess that right-hand side should technically, Simone, be a little bit shorter than the left-hand side, but whatever. I do know the resultant. The resultant is supposed to be due east. Not only that, I know this angle here is 38 degrees. So here is the momentum of the rock initial that I'm trying to find. Now, I also know that this angle here is 48 degrees, which means I can pull out the Z trick. This angle here is 48 degrees, and this question just became a lot easier, because in any triangle, if I know 2 angles, I know 3 angles. Because what does every triangle add to? 180, so I can go 180 minus 38 minus 48, and I get this angle up here is 94 degrees. Why does that help? I think I can actually pull out the sine law. I do have a pair. In fact, I have 2 pairs, that one or that one. So I'm going to go sine of 94 divided by mystery momentum equals, oh heck, I'll use the 38 and the 22.14. You could also use the sine of 48 over 26.24. You'll get the same answer. 22.14 times the sine of 94 divided by sine of 38. I think that's how I would get this by itself. I lost some of you. Let's do that. I think the initial momentum is going to be 22.14 times the sine of 94 divided by the sine of 38. You would multiply the p up to the top, divide the sine over, times that over. Do you get 35.8737? Just to show you that it would work the other way, you could also have used, let me see if I can do this on the fly here without rewriting it, sine of 48, so you could go 26.24 times sine 94 divided by sine 48, and you should ideally get something really, really close to the same. Oh, 26.24? Yeah, is that right? I don't know. I'll double check it in a second. Anyhow, the velocity initial, or the speed initial, is going to be 35.8737 divided by the mass of the first rock, which was 3.2. Do you get 11.2 meters per second? Let me just quickly double check if I use the other angles. So it would be, I use the 38, it would be sine of 48 over 26.24 equals the sine of 94 over mystery angle, or mystery side. 26.24 sine of 94 divided by sine of 48 equals, divided by the mass. We're a bit off, which is concerning, and it may very well be, if you got 11.0, I'll take that as well. I may have made up an impossible collision when I made up these numbers. I may have to change this for next year. But you will get 11 meters per second. If you got that, 7 out of 7. Otherwise, how would I give out part marks here? 1, 2, 3, 4, 5, 6, 7, something like that. Yes. Can you give yourself a lovely score out of 28? Oh, I forgot to put my student's name on here, didn't I? Give yourself a score out of 28. Make sure your name is on them, and could you pass them in?